All right, here is a second example of a classic related rates problem. This one states a 10-foot ladder is sliding down a wall. The bottom is 6 feet from the wall and moving away at 1 foot per second. How fast is the top of the ladder sliding down the wall at that moment? So first, we are going to just list out our givens. I would probably draw a picture for this as well. Even in geometry, I just like being able to see this. So basically, this is 10 feet, right? The length of the ladder. And then the bottom is 6 feet from the wall to start. And then, of course, it's sliding away from the wall like that, moving in that direction. So again, our givens, ladder length is 10 feet, horizontal distance from the wall is 6 feet, and then the rate at which the bottom is moving is dx dt equals 1 foot per second. Now, again, this is probably the hardest step. We're going to define our variables. X is basically our horizontal distance. Y is basically our vertical distance or height on the wall. So that's here. And then we have to figure out how to relate all of these variables. So again, you have to be able to identify that this is a right triangle, and we're going to use the Pythagorean theorem here, which is just a squared plus b squared equals c squared, or specifically in our case, x squared plus y squared equals 10 squared, which is just the same as 100. Now we are going to go ahead and differentiate both sides with respect to time. You can see the original equation there. Again, I'm not going to go over that in depth, but that is the derivative there. Next, we're just going to plug in our givens. So we know that x is equal to 6. And I should note that I actually already did the algebra here and went ahead and solved this for y. So I didn't really make that clear here now that I'm looking at my work, but basically I took x squared plus y squared equals 100. I plugged in 6 for x, so 6 squared plus y squared equals 100, and then I went ahead and solved that for y. So that's how I got this equation here. I basically just subtracted that over, and then I took the square root. So I got y equals square root of 100 minus 6 squared, which simplified down to root 64, which is equal to 8. So now I know that x equals 6, y equals 8. One little side note, depending on how comfortable you are with this is actually a 3, 4, 5 triangle. So really you didn't even need to do that. If you could identify that, you would have already known that y equals 8. Anyways, going back to it, now we're going to go ahead and take both of those values for x equals 6 and y equals 8, and we are going to plug it into our differentiated equation here. So you can see that's how I got that step. Now let's go ahead and move on. Now we're going to take that. Actually, let me make it so you can see that. Okay, now we're going to take this equation here. We are going to simplify, and then we are going to isolate and solve for dy dt. Again, not going to go through the algebra in depth, but feel free to pause the video and do it on paper. Then we would get dy dt equals -3/4. So again, probably most important step is being able to interpret this answer. So to interpret this, we would say the top of the ladder is sliding down the wall at a rate of 0.75 feet per second when the bottom is 6 feet from the wall. Kind of a little note on that with the negative sign, you do have to be clear which direction it's going, right? So that's why we're saying the ladder is sliding down the wall at a rate of 0.75 feet per second. We're kind of acknowledging that it's negative there.